OSI, or Open Systems Interconnection, is a model developed in the early 1980s that manages the standards for communication between computer systems. Users typically run client-server applications on their computers, such as web browsers, email programs, FTP clients, or remote desktop connections. Each of these programs requires communication with the server in order to function. Once the user submits a request, it goes down through several layers, known as the OSI layers. Layer 7 is the application layer, which defines the application user interface responsible for displaying information received by the server. Examples are email, web browsers, and FTP clients. Layer 6 is the presentation layer, which ensures data sent from the server will be readable by the client. Encryption and decryption take place at this layer. Layer 5 is the session layer, which is responsible for opening, closing, and managing a session between different applications. For example, if you are running both a web browser and an email program, the session layer ensures data received from the web server is returned to your web browser. Layer 4 is the transport layer, which is used to establish the TCP session we discussed previously. TCP requires a connection between two systems, whereas UDP, which stands for User Datagram Protocol, doesn't require a session and is used for more simple message transmissions. Both TCP and UDP use port numbers to establish host-to-host connections. Well-known ports include ports 20 and 21 for FTP, 22 for Secure Shell or SSH, 23 for Telnet, 80 for HTTP, and 443 for HTTPS. Layer 3 is the network layer, which is responsible for packet forwarding and routing using IP addresses. This is where you'll find the client IP address. Layer 2 is the data link layer, which transfers data between two nodes on the same local area network using the Media Access Control Address, or MAC address, of each system. A MAC address is a unique identifier for the network or wireless card on a computer. Your computer may receive a different IP address every time you connect to the ISP. However, the MAC address for your network adapter never changes. Here's an example of a MAC address. The first 6 hexadecimal values identify the hardware vendor, and the last 6 values uniquely identify every adapter distributed by that vendor. In case you're curious, a 6-digit hexadecimal value is the equivalent of 16,777,215 unique decimal values. That means there are enough unique MAC addresses for over 16 million adapters from over 16 million network adapter vendors. Or more simply, there are over 281 trillion unique MAC addresses available. Finally, Layer 1 is the physical layer, which identifies the type of physical hardware for the computer, which the data link layer uses to translate data for the correct type of signal. From there, the request is off to the internet using a network cable or a wireless network signal.